Okay, so for the third case, we have to solve equation 40 because ODE for x leads to non-zero equation, non-zero solution. Okay, so here for wave equation, this will be the second order ODE. So we solve this, m squared, the characteristic equation here, plus 4p squared, p squared equal to 0. Okay, this actually will becomes the complex roots m squared equal to negative p squared. Okay, so negative square root will becomes the negative plus minus I. So square root of 4p squared, square root of 4 is 2, square root p squared becomes p. So we have plus minus 2pi. Okay, so we will have the solution for t here, complex roots. So t in terms of small t, so the solution is t equal to g cos 2pt. Okay, cos 2pt plus h. Okay, sorry, I have problem with this. Gh here sin 2pt. And then okay, so p already known, so we can replace, actually becomes g here becomes cos 2n pi over 3t. Then we have here plus h sine, replace p, so 2n pi t over 3. Okay, this is cos. Okay, so all the proper writing like this. Okay, we have this tn here. Okay, so for case negative lambda, we will have u equal to x here multiply with this g. Okay, we'll have fn. Here's sine. Okay, you multiply, then we can minimize the number of constants if any. So here f sine n pi x over 3 multiply with this. Okay, there appear g cos t. Okay, 2n pi t over 3. We have h sine function n pi 2 n pi t over 3. Okay, so here we can combine. Here we have fn multiplied with gn, so we can bring fn inside this bracket and fn multiply with hn. So we combine original. We have 3 unknown here. So when we combine, there will be only 2 unknown. So for the third case, we have sine n pi x over 3 multiply fn combined with gn. So I can rename as a new constant j, for example, gn cos 2n pi t over 3. Then we have plus fn multiply with h. I will rename as another unknown k, for example, kn sine function here, sine 2 pi nt over 3. Okay, so for the first case, 0 solution. The second case, 0 solution. We have only the third case, the non-zero solution. So after we sum all solutions below here, there will only appear this part. Okay. Okay, for sum all solution here, we already discussed for the previous example solution. In this case, the first solution is 0, the second solution is 0. So we only have the third case, u3. We have sine and pi x over 3 multiply with jn cos 2 n pi t over 3 plus kn sine. Okay, please check my answer. Okay, so here looks different. Okay, for the wave equation with this type of boundary condition. So next we use initial condition. There are two initial conditions. The first one is, okay, from the question, the initial condition, we have two initial conditions here. The first one is u at point t0 equal to 2. The second one, ut or del u del t at point t0 equal to 1. Okay, so in here we have to use the two initial condition. The first one is u x at point t0 equal to 2. The second one is ut at point t0 is equal to 1. Okay, so for the first first initial condition here, this means t equal to 0, u is equal to 2. Okay, so means here we can replace directly for the first boundary condition into this. Okay, so u equal to 2, the left hand side becomes 2 equal the right hand side. T equal to 0, so x remains here. T here we have t0, so cos 0 equal to 1. This part sine here t0, so sine 0 is 0. So we only have this part jn. So it actually becomes this n equal 1 infinity jn sine and pi x over 3. Okay, so actually we can apply here the odd Fourier series for this from the first boundary condition. And for the second boundary condition, it is del u del t. So del u del t comes from here. Since here del u del t, so we have to differentiate this function first with respect to t. Okay, before we can use this condition. Okay, so below here, okay, there will be twice of Fourier series you have to do here for wave equation. Okay, because applying the second condition del u del t, we differentiate this first. We have ut equal to sign here remains because it is x. Okay, we only differentiate with respect to t, the term in the bracket here. So we have summation n equal 1 infinity. Sign remains and pi x over 3. So term in the bracket contains t, so we have to differentiate. We have 2 negative n pi over 3 jn. Differentiate cos is sine 2n pi over 3. Then differentiate sine is cos, so we have 2n pi over 3 kn. Sine is cos. Okay, so cos 2n pi t over 3. Okay, so now this ut, so now we can replace t0, ut equal to 1, so means ut on the left is 1, on the right t0, here remains, here t0, so sine 0 is 0, so eliminated this part, here cos 0 equal to 1, so we have this part, so this part we have summation n equal 1 infinity. From the square bracket here, we have this, okay, 2n pi kn over 3. Then we still have this outside bracket, so sine n pi x over 3. Okay, so we have to find jn and kn for this case using the Fourier series. Both are odd Fourier series. Okay, so this is clear, I think. We can find Jn using the formula for Fourier series. This actually 2 over 3 integrate 0 to 3. Fx is 2, so 2 sine n pi x over 3. Okay, you solve this, you will get the answer for Jn. Okay, for this part, actually using the Fourier series formula for like this, you will get all this, okay, together with the coefficient here. So means using the odd Fourier series, you will have to find 2 pi n 2n pi kn over 3 equal to 2 over 3 integrate from 0 to 3. Fx for this case is 1. So 1 multiply with formula sine. So sine n pi x over 3 dx. Okay, so because this we compare with the Fourier series formula for odd function, fx equal to summation bn. Okay, sine n pi x over l. Sorry, bad writing. Okay, so here bn actually all this. Okay, that's why be careful here. We have to take all this to find the constant. Okay, so the answer that you get here is actually consists of all these, but what we need to have is actually only kn. So you need to find kn equal to the answer that you get here. You have to divide by this coefficient. So means the answer here is 3 over 2n pi multiply with the answer that you get in this bracket. Okay, so you have kn from here, you have jn from here. So finally, don't forget, you have to take this back, replace jn that we get, replace kn that we get. That will be the final answer. Okay, please check the answer here.